do another example here. So we have an elevator that has a mass of 600 kilograms, not including the passengers. The elevator is designed to ascend at a constant speed, a vertical distance of 20 meters, 5 floors, in 16 seconds. And it is driven by a motor that can provide up to 40 horsepower to the elevator. What is the maximum number of passengers that can ride in the elevator, assuming the average passenger has a mass of 65 kilograms? All right, so we're given the average power and we're trying to find the number of passengers that can ride in this elevator. Now, a slight problem here is they told me the horsepower, 40 horsepower. So I'm gonna have to convert that. And so 1 horsepower is 746 watts. So we will have to use that conversion up there at the top of the page. And so since this elevator is going between 2 points, I'm gonna use the work kinetic energy theorem to find this work. And what we're probably gonna see here is, so work in, all right, there's no friction. It's moving at the same speed at the top and bottom, so K1 and K2 are the same values, so they cancel out. And I'm gonna call the ground 0 height. So now I have work in equals UG2, which is MGH. And so this mass here, that's where those passengers' masses are hiding. Okay, so let's kind of put this all together. So now I have power times time is equal to work, which is equal to MGH. Okay, so I'm going to solve for that mass. So I have power times time divided by GH is equal to the mass. So I know the power. I just did my conversion here. This was, well, how much was that? 29,840 watts of power. I know my time, it's 16 seconds. I know my height, it's 20 meters. Now the mass, on the other hand, is 600 kilograms, that's the elevator, plus the people. And so there's some number of people, I'll just call it N number of people, times 65 kilograms a person. So now I just need to solve for that N value. All right, so now I have power times time divided by GH minus the 600, all divided by the 65, will give me the number of people. So let's put those numbers in. So I have that 29,840 times 16 seconds, all divided by 9.8 times the 20 meters, minus 600, all divided by 65 will give me the correct number of people. And of course, we're going to round down so that we don't end up with some partial people on our elevator. So 28 people can fit on this elevator safely. Now, I don't know if you've been on an elevator, but you should probably go look. Go to an elevator and look inside and see how many people can this elevator hold. And typically, if it says 28 people, you're not going to be able to shove 28 people in that elevator because it doesn't want to run into the scenario that you ever reach the maximum capacity of that motor. So that elevator might only be able to hold 15 people. In some cases, I've been in elevators where it wasn't meant to hold. You know, it was, hey, I bet we can fit 12 people in this elevator. Let's say 12, let's make it a motor for 12 people. All of us crammed in on this elevator in a hotel. I'm like sitting on my bag, like I got a kid in my arms, and it wouldn't go. The doors wouldn't close because it was overweight. And so then we had to have some people get off in order for it to run. But side story on a video. Really, Mr. Foster?